Greetings YouTubers, Michael here again on the final installation of the unboxing process before I start assembling this plane for the Hangar 960cc Xcub, which I'm looking very much forward to as it's a dark and gloomy day here in Melbourne today, and it doesn't seem as though that the sun wants to come out. Very cloudy and raining all day. Before I start the assembly process and before I start unwrapping, I wanted to just run down and tell you guys what electronics that I chose for this build. Now, in the previous video, I did the DLE 55RA, and on the previous video before that, I unboxed and showed you the plane. So in this one, I'm going to focus on the electronics, what servos, what receiver I decided to go with. So without further ado, here we go. Now, special thanks to Spektrum for making this product and Horizon Hobbies. I decided to go with the SPM-AR 20310T 20-channel telemetry receiver with onboard telemetry, so no need for a TM1000 anymore. As those of you who fly with Spektrum and have telemetry, you would know that you'd need another telemetry receiver to receive telemetry. In this case, it's built in. You've got your ports on the side there for RPM, temperature, X bus if you want to expand and put more telemetry, and what else do you have? You've got voltage. So it does come with a voltage wire already, so you don't need to get a voltage sensor. It does come with it in the box for your flight pack. Then you've got your RPM, which I did purchase and I do have, and also the temperature. So the most important aspects when it comes to flying gas planes is RPM, so you know how much or how fast your engine is spinning in midair, not on the ground, in the air. And the other thing is temperature. A lot of people overheat their engines and not know that because of obviously if it's in the air, you can't just simply place your finger near the engine, or place a laser temperature reader near the engine to see how hot it's running. It's good to know how hot your engine is in midair, so you have to land straight away if it's overheating. So you can adjust to richen it up a little bit. So I always fly with the telemetry on. I actually have a rule with myself: I don't fly unless my telemetry is working. So at least then I know exactly what my engine is at temperature and also the RPM rating. So I'd like to shout out to Horizon. This is not a paid representation of their company. I did purchase this with my own money. Just a quick disclaimer there. But I'm so happy with the products that they bring out, especially their electronics. Now, there are a lot of people out there that fly with Jetty, or Jet-I, I don't know how to pronounce it, but I've never had one, so they fly with very expensive stuff. But if you're looking to build a more budget plane that still wows the eyes at the field, you can't go wrong with Spektrum. Now, electronics-wise, if you had an endless budget, and you can max out your credit cards, for example, you could go all the way up to, for this build, it's under $4,000 as it flies with everything I have. But I could have easily spent up to $8,000 just on electronics and everything that I could have done. So this system I highly recommend. I fly out of a DX9, which I'll be upgrading to a 20-channel new Spektrum transmitter very shortly, so I can complement that and use every feature and every pop that it has. The second thing I wanted to show is the servos. Now, the plane will be approximately just under 14 kilos or 13 kilos roundabout laden, because I'm flying gasoline, not electric. Electric flyers do enjoy the benefit of more power and also instantaneous torque, as obviously electric motors will have instant torque, whereas gasoline engines don't. But they do suffer from obviously a bit more weight because they do have to fly with two 6S battery packs. As an example, two 6S 5000s will weigh around about, I'd say the better part of 1.5 to almost 2 kilos on top of the electric motor itself, which weighs around about 700 to 800 grams. And the speed controller, which will weigh around about 200 to 300 grams, depending on which speed controller you go with. So it's a fair bit of weight, but then again, they have more power, and they can spin a bigger prop with more pitch. So the servos that I chose to go with are the D64MW high voltage super torque servos from HITEC. Haven't had any issues with HITEC servos before. At the moment, I use Spektrum servos on my Super Cub, and they're brilliant. But I did have, as I said before in the earlier video, this is my, I think, 27th build. So most of those builds utilized HITEC servos, and I've never had an issue with them. But I have not used them for at least 5 or 6 years now. So these are the new version servos, which, if anything, should be and will be better. They're rated at, and I will be using 7.4 volts. They're rated at 12.9 kilograms per centimeter, 12.9 kilograms per centimeter, or 180.1 ounces per inch. That's a lot of weight per surface. I mean, this aircraft, as I said, is it'll be just at 13 or 14 kilos. Haven't weighed it yet, but excuse me. But it should suffice. So at 7.4 volts, at 0.17 seconds 0.17 seconds to 60 degrees, at 12.9 kilos per centimeter, at 180.1 ounces per inch. The servo weighs 60 grams. I'll be utilizing 8 of these servos, and 1 for the choke, which is the HS430BH high voltage standard servo. So this is not a digital servo. Now this one here is just for the choke, so it's not as important as all the other surfaces. So you'll need 2, 1 on each side of the plane for the ailerons. You need another 2, 1 for each side of the flaps. You need 2 for the elevators, so 1 for each elevator half, 1 for the rudder, and do not skimp on the throttle, because that's a very important aspect of the plane. A lot of people put cheap servos for the throttle. In this case, I will not do that, and I'm putting the same servo as every other surface for the throttle. Then you've got your choke, or you can use that for the tow servo. This does come with a tow hitch, which will be mounted just on the top here somewhere, which Hangar 9 and Horizon have put in the box. It's a good system to have, especially for this size of aircraft. There's a lot of people who buy this aircraft will be using it to tow other aircraft in the air, and that is that there. So that can be used to release the tow hitch when you're in the air. So that covers basically all the electronics that I'll be putting in this, the receiver and the servos. On upcoming videos, I will highlight the AS3000 once it arrives, because I am putting a AS3X, AS3000 gyro on this, which I've never flown with before. I've never flown with a gyro on a plane before. I've had experience with them on helicopters, but not planes. They do very well in helicopters, and they make a world of difference with flying on gyros with helicopters. As when I started flying helicopters, they didn't have that technology available. The best that we had back then was heading lock gyros, which basically just kept it in the heading of whichever way you pointed the nose. But after that, they came up with gyros that handled roll, pitch, and yaw. So every aspect of flying. So in theory, if it works on a helicopter, it should work as well, if not better, on an aircraft, as it's only moving forward. Basically, a gyro counteracts the opposite movement, if you didn't prompt it to move in that direction. So for example, if you have an aircraft And you're flying forward, that's the tail, that's obviously the nose, and the wind is coming from the right side. If the wind tries to roll the aircraft to the left, the ailerons will counter that by giving it down aileron to the right, so it keeps it straight flying. And then that's the same goes for the pitch, which is up and down movement of the nose and tail. So if the wind tries to pitch the aircraft up, it will counter that by giving it down elevator, and it'll actually keep it straight. And yaw, same thing. That's why they call it a 3-axis gyro, because 3-axis is you've got roll, pitch, and yaw. So the yaw part of it is the rudder. The rudder will then hold it in that direction, whichever way you're flying. So if the wind tries to push the tail this way, because you've got a very big vertical stabilizer, wind tries to obviously push that, and it does affect it in flight. What a rudder will do is what the gyro will do is it'll counter it by giving it some rudder to keep it straight. In helicopters, obviously, you've got governors as well for the motor, which in this case we won't be using. It's no need to use it on an aircraft because you want to be able to manually control your throttle. That concludes the electronics overview of what I'll be putting in this plane. I'll now be assembling the plane, and I'll be taking videos as we go. It won't be a step-by-step tutorial. This is just basically to show how I assembled it. And what I did, how I did it. I'll be detailing them as it's done, so it won't be shown as I'm building it. And the reason for that is I have nobody to hold the camera for me. As I said, at the moment I'm still a rookie in terms of making videos. I'm an amateur at it. If I get enough views and enough likes and enough decent comments, I will be making more videos and investing in better equipment, as I've said previously. But until then, it's a good thing, I guess. I've got to get my foot through the door and start somewhere with videos. It's a hobby that's progressing around the world. However, the more we progress, the more competition we get, and the more we need to be more careful, because obviously technology these days is a good thing when it comes to controlling unmanned aircraft, but the rules are being overlooked. The rules are being looked at each day by governing bodies, and they're getting stricter. So where I live, it is pretty much illegal for me to fly this at most parks. It's too noisy and too big. However, at some parks I can fly it at my own risk, but it is at my own risk. So I will be looking at joining a club very shortly, as I'm not a member of a club yet. Been flying for 15 years, but never seen the need to join. And the reason for that is just the politics. I don't like the BS that comes with being in a club, especially when you've got a lot of... and this is nothing against old-timers, but you got old-timers that basically tell you which way's up all the time. You should do this, you should do that. Well, mate, it's my hobby. I built the plane, I fly it, I want to enjoy it, I don't want to talk bullshit with you. So that's the reason why I didn't want to join a club in the beginning. But I am hunting for a decent club that I can join once this aircraft is built, mainly for insurance purposes. At least at a club you're insured. There's less risk of you hitting or damaging something, and more importantly, there's less risk of you hitting a bystander or a child that's walking down the park with his dog and killing them. And this is more than capable of killing someone if you hit them at a bad spot. So factoring all those in mind, it's very important once you get to this scale of aircraft to start to look at clubs to join. There are membership fees, obviously, and they are very expensive, so you have to be serious, extremely serious about your hobby to pay the amounts that they require for you to join. And that's the unfortunate aspect of this hobby, is it does get expensive. This plane as it flies is just under $4,000, as I said, and that's with medium grade electronics. Nothing in this build is top of the range or top spec. I could have gone a twin cylinder engine. I could have gone better servos. The receiver's the best I could get for what I could get, and the transmitter I have. But that's one thing I wasn't prepared to skimp on, so I got the best that I could. but everything else I had to sacrifice a little bit on the specifications. My original thoughts and plans were to get MKS servos with a DA70 motor and a lot of other things that just would have blown the budget out of proportion. I think at one point I got it up to $7,500 as it flew with the airframe. But to cut $3,000 off that and fly it at just under 4,000 Australian dollars, that to me is, I can live with that. Just don't tell the wife. So thank you so much for watching, guys. Until the next video. Hopefully you watch this video. You don't get too bored with the rhetoric. But hopefully it helps others as well. And it helps encourage others wanting to start flying to see that it's not hard. It just takes a bit of saving and a little bit of patience, especially with building, as you will make mistakes. And you have to learn from them, obviously, as in life. So once again, I thank you. This is Michael signing out until the next video.